Let's say I'm throwing a paired dice. Each time I throw it, I can get a number between 1 and 6. Now imagine I throw the dice 20 times and record all the results. At first, it seems unmessy, but if I arrange it in ascending order, it becomes a lot easier. When I organize the results in table, I might see something like this. I got 1 5 times, 2 4 times, 3 3 times, and so on. Once I recorded the information like this, a very natural question comes up. What was the average number or mean number I got from those 20 throws? We already know how to calculate the mean. We add up all the numbers we obtained and divide by the total number of throws. But instead of working out the sum individually, the frequency table allows us to calculate the total much more efficiently. For example, I got the number 2 4 times. So instead of writing 2 plus 2 plus 2 plus 2, which is equal to 8, we simply multiplied the value 2 by its frequency 4. 2 times 4 is 8. Similarly, 1 appeared 5 times, so 1 times 5 is equal to 5. And adding 1s also equal to 5. If 3 appeared 3 times, then 3 times 3 is equal to 9. We repeat this process for every value, for 4, for 5, and for 6. After calculating each value multiplied by its frequency, we add those results together, which is 62. That final total is exactly the same as adding all 20 numbers individually, which is also 62. But the method is far more organized and elegant. Now divide that sum with 20 and we get the mean value of my throws, that is 3.1. Now let's try another problem. A teacher has recorded the number of books read by 25 students in a month. The data is organized in this frequency table. One book was read by 4 students, 2 books by 6 students, 3 books by 7 students, 4 books by 5 students, and 5 books by 3 students. The teacher wants to calculate the mean numbers of books read per student. So, how do we do that? Just like before, instead of writing all the values out, we multiply each number of book by its frequency. 1 times 4 gives us 4, 2 times 6 is 12, 3 times 7 is 21, 4 times 5 is 20, and 5 times 3 is 15. Now we add all these results together. This gives us a total of 72 books. This number represents the total number of books read by all 25 students. Finally, to find the mean, we divide this total by the number of students, which is 25. So 72 divided by 25 gives us 2.88. And this is the mean number of books read per student. Now in GCSE, you may be given a frequency table where the data is presented in a slightly different form. In this case, it becomes impossible to calculate the exact value of the mean. For example, imagine a scientist measuring the heights of 20 tomato plants. Unlike a dice which only produces specific whole numbers from 1 to 6, the heights of tomato plants are continuous. A plant could be 12.3 cm, 12.8 cm, 13.1 cm, 14.6 cm, and so on. If the scientist recorded every exact height, the list might become long and difficult to organize. So instead, the results are grouped into intervals. The organized data in the table might look something like this. There are 4 plants with heights between 10 and 15 cm. There are 7 plants with heights between 15 and 20 cm. And similarly, 6 plants with heights between 20 and 25 cm. And so on. Now notice something important. We no longer know the exact heights of the plants. For example, in the 10 to 15 cm group, we only know that 4 plants have heights somewhere between 10 and 15 cm, but we don't know their precise values. So, how can we calculate the mean if we don't know the exact numbers? This is where we make an estimate. To understand the idea, imagine we still had access to the original list of heights. The first 4 plants had heights that added up to 52.8 cm. However, once the data is grouped into intervals, we lose those exact values. Instead, we represent each interval using its midpoint. The midpoint of an interval is found by adding the lower and upper boundaries and dividing by 2. For the first interval, we would add 10 and 15 and divide it by 2, which would result in 12.15. So we assume that each of the 4 plants in this group has a height of about 12.5 centimeter. If we add these estimated values together, which is the same as multiplying 12.5 by frequency 4, which is equal to 50. As you can see, this estimated total of 50 centimeter is quite close to the actual total of 52.8 centimeter. This shows why using the midpoint gives us a reasonable estimate. We repeat this process for each interval. For second interval, the midpoint is calculated to be 17.5 centimeter. Similarly, for the third interval, the midpoint is 22.5 centimeter. And for the fourth interval, the midpoint is 27.5 centimeter. Now instead of multiplying the exact values by the frequency, like we did with the dice example, we multiply the midpoint of each interval by its frequency. For example, 17.5 times 7 is equal to 122.5 centimeter. And 22.5 multiplied by 6 is equal to 135 centimeter. And similarly, for the last interval, 27.5 times 3 is 82.5 centimeter. After calculating these, we add the results together to get an estimated total height of all 20 plants, which in this case is 390. Finally, we divide the total by the overall frequency, which is 20. This gives us an estimated mean height. Now let's try a problem involving group data. A table shows the weekly earnings of 20 people working at a shop. By the way, a very similar question appeared in a GCSE Foundation non-calculator exam. We are asked to work out an estimate of the mean weekly earnings per person. Now notice that the earnings are given in intervals, not exact values. This means we cannot calculate the exact mean, instead we have to estimate it. To do this, we begin by finding the midpoint of each interval. These midpoints will act as representative values for each group. For the first interval, we add 150 and 250 and divide by 2. This gives us a midpoint of 200. For the next interval, the midpoint is 300, then 400 for the third, 500 for the fourth, and 600 for the final interval. Now that we have the midpoints, the next step is to multiply each midpoint by its corresponding frequency. This gives us an estimate of the total earnings in each group. So we calculate 200 times 1, which is 200, 300 times 11, which is 3300, 400 times 5, which is 2000, 500 times 0, which is 0, and 600 times 3, which is 1800. Now we add all of these values together. This gives a total of 7300 pounds. This represents the estimated total earnings of all 20 workers. Finally, to find the mean, we divide this total by the number of people, which is 20. So 7300 divided by 20 gives us 365 pounds. And this is the estimated mean weekly earning per person.